Hey everybody, good morning. It's Mr. Smith here. It's about 9:20 on Friday, just making a video for you so you know what's going on. We talked about a lot of this stuff, and the point of this video is just to make sure that you hear it again, excuse me, and know how to do the problem. So I'm going to go quickly through the part that we already covered in class, which is defining the sine, the cosine, and the tangent. By the unique sides, right, the hypotenuse is not a relative designation. It is a fixed side of the triangle. It's opposite of the right angle. However, depending on the angle that you're looking at, the other two positions are relative to that angle. So for example, if I'm looking at angle T here, then the side that is opposite of it, of course, is the one that I just drew the arrow to. So we can say that the opposite side can be named in this way, and we can create these ratios called the sine, cosine, and tangent ratio. And going with that, we can then say the adjacent side is here, and we should be good to go to set up these different ratios. So what we did in class was we said we have an angle called, in this case, alpha, and relative to that angle alpha, there is an opposite and an adjacent side. This side is fixed. It's across from the right angle. It's the hypotenuse. So based on this, we can say, we have our SO, CA, TOA, where the sine is the opposite over the adjacent, etc. Excuse me. So we have to find the sine of alpha. We can do the opposite of alpha, which is 8, over the hypotenuse, which is 17. The cosine of alpha is the adjacent to alpha, which is 15, over the hypotenuse, which is 17. And the tangent is the ratio of the opposite over the adjacent. And we're done. Example 2 is very similar. Example 2, we're now talking about angle T, which is over here. And again, really, the drawing doesn't matter. You'll always be taking the sine, cosine, or tangent of an acute angle in a triangle like this. So the location of it doesn't matter. What matters is the location of the sides relative to that angle. So if I'm doing now the sine of T, I have to ask myself which side is opposite of T and what's the hypotenuse. So opposite of T is 7 and the hypotenuse is 25. The cosine of T is the adjacent over the hypotenuse. And that's 24. The adjacent side is 24 and the hypotenuse is 25. And the tangent of T is the opposite over the adjacent. So that's going to be 7 over 24. And these trig values are just ratios. They're simply just ratios. In some cases, they could be written as decimals, but for our purposes, we're going to write them as fractions. All right, we reviewed the Pythagorean theorem, so I'm going to go through like examples 3, 4, and 5 here. So we have triangle ABC is a right triangle, where the right angle is actually called C. The location of A and B really don't matter. Now, I'm looking at the problem, and it says like A is 6 and C is 10. I'm going to put A here and call this 6. I'm going to call that C. Lowercase letters, as you probably know, refer to the side opposite of the angle. So like the uppercase A is here and the lowercase a is there. Uppercase C is here, lowercase c is there. Now we've got a right triangle with two sides that are known. We'll probably need to find this third side because it says find the sine, cosine, and tangent. Like with angle A, I know the opposite is 6. I know the hypotenuse is 10, but I don't know the adjacent side. So I'm going to set up my a squared plus b squared equals c squared, where the missing side could either be a or b. It doesn't matter. So we have 6 squared plus b squared. Hard to tell the difference between the 6 and the b, right? equals 10 squared. And you get 36 plus b squared is 100. B squared is 64 and b is 8. And now that I know b is 8, we can now find sine, cosine, and tangent for angle A. So I'll put this over here. Sine of A is the opposite over hypotenuse. That's 6 over 10. In lowest terms, it's 3 over 5. The cosine of A is the adjacent over the hypotenuse, which in lowest terms is 4/5. And the tangent of A is opposite over adjacent, 6 over 8, which is 3 over 4. And these are our trig ratios, and that's it. Number 4 gives us a little bit less information, but it's in the context of a right triangle. So let's draw a right triangle, and we have some angle that we're referring to. Now remember I said you'll always be referring to an acute angle. So one of these guys here, right? I'm going to pick just the one on the bottom. So I'm going to call that theta. Now the sine of theta is 4/5. That means the side opposite theta is 4, and the hypotenuse is 5. So I'm going to set up my, 1 second please, 4 and 5. I can set up my Pythagorean theorem and say that, 4 squared plus b squared equals c squared, right? C is always the hypotenuse. So 16 plus b squared is 25. B squared is 9 and b equals 3. That's my missing side. And now that I've got all three sides, I can now do the the cosine and the tangent of both of these remaining angles. So let's do it. All right, so it should be easy to do. The cosine of theta is the adjacent to theta, which is 3, over the hypotenuse, which is 5. The tangent of theta is the opposite of theta, which is 4, over the adjacent, which is 3. And we're done just like that. Number 5 is the same basic problem, but what you're going to find here when you do Pythagorean is you're going to get some radicals rather than like nice integers. So let's say we have some angle B whose cosine is 5 over 7. That means that the adjacent side to this angle is 5 and the hypotenuse is 7. So I can find this missing side by simply doing 5 squared plus b squared equals 7 squared. Turns out that b squared is 24 and b equals radical 24, and that's 2 radical 6 when you simplify it. So this side right here is 2 radical 6. And now I can find the sine and the tangent, for example. So let's do sine of theta. Is it theta or that's actually b, sorry. Sine of b is the opposite of b, 2 radical 6, over the hypotenuse, which is 7. The tangent of b is the opposite of b, which is 2 radical 6, and 5 is the hypotenuse. And these are our ratios that they wanted us to do. And the last thing we talked about, I'm going to cover the other stuff. Actually, we're going to do example 8 also. So the quick thing about Pythagorean triples is this idea that if you do the Pythagorean theorem and you get a set of integers that satisfy the rule, like up above, let's see, I think we had 3, 4, 5, right? Like I'll highlight this. We had like 3, 4, and 5, 6, 8, and 10. So like 3 sides that are integers that satisfy the Pythagorean theorem. Those are called Pythagorean triples. And they're really just meant to be a convenience. If you understand like what they are, they may save you time. You don't have to actually do the Pythagorean theorem. You're like, oh yeah, I know that 3, 4, 5 is a Pythagorean triple. I'm not even going to do it. I've got sides of 3 and 4. The hypotenuse must be 5. That kind of thing. Okay, so essentially, example 6, show that 3, 4, 5 is a Pythagorean triple. You simply take your 3 squared, your 3 squared, and you're 4 squared, and when you add them together, it should be 5 squared, right? So is this true? 9 plus 16 equals 25? Yes, it's true. It's a Pythagorean triple. Example 7 says, now scale it, multiply it by 2. Does the same thing happen if you do 6 squared plus 8 squared equals 10 squared? 36 plus 64 equals 100. Yes, it's true, right? Of course it's true. So hang on a second. All right, so Pythagorean triples, in addition to their multiples, are also, you have Pythagorean triples. Their multiples, integer multiples, are also Pythagorean triples. So like not only 5, 10, 13, but 10, 24, 26 if I multiply by 2. Or if I multiply by 3, I get 15, 36, 39. Just, try to learn as many as you can. It just helps you. It's not like, okay, on the quiz, what is name a Pythagorean triple? It doesn't work like that. It's a thing for convenience where if you know them, it just helps you out. Okay, the last thing, I'm going to save the bottom part, the special right triangles, for when we get together next time. So example 8 just says find the measures of the missing angles of the triangles below. So looking at example 8a, I want to find side x. Well, I've got an angle 49, and I've got the, relative to the 49, I've got the opposite, which I want to know, and the hypotenuse, which I already know. So isn't that really the sine function, which combines the opposite and the hypotenuse? So what I can do is I can say, well, the sine of 49 degrees equals the opposite x over the hypotenuse, which is 16. And if I just multiply both sides by 16, I'll get my answer. I'll calculate it in just a minute. I don't have a calculator at my fingertips right now. But I'll pull one up real quick in Desmos. So let me see, Desmos. I'm wasting time here, scientific. Okay, I'll do that in a second. And then the other one, I'll change color here. The other one is to find y. Well, again, I've got 49 degrees. Y is the adjacent side, and 16 is the hypotenuse. So that's the cosine. So I have the adjacent and the hypotenuse, and isn't that just cosine theta? So I'll say the cosine of 49 degrees equals y over 16. And then if I multiply both sides by 16, I get 16 cosine 49 equals y. And now I'm going to do that. So let's see, I'm in degrees. 16 sine 49. This is apparently 12.1 for x. And y is 10.5. And there you go. Oh, and by the way, the missing angle here, which we have to find also, we have to find all missing sides and all missing angles, is just, well, this angle is 90, and I've got a 49. So isn't that missing angle 41 degrees? It's going to turn out that the two angles that are the acute angles in a right triangle will add to 90. Okay, lastly, we have, excuse me, this last one, a right triangle where I know two of the sides. So I can find the third side, c, by doing c squared equals a squared plus b squared. And I think that's 4 plus 9. C squared is 13. So c is radical 13, which is just fine. We'll leave it like that. Now the problem is here we don't know the angles. So I want to know like angle A, for example. And what we're going to do is something new you'll learn if you don't know this already is normally what we've been doing is taking the sine function, for example, and like plugging in an angle and getting a fraction, right? The input is an angle, the output is a trig value. Now, in this case, what I know is I know that the sine of A, let's say, I'm not going to use the sine, let me do tangent. Because you see this angle A, I know the opposite and the adjacent. I mean, I know the hypotenuse too, but I'd rather work with the integers. So I have the tangent of A equals the opposite 3 over the adjacent 2. And to solve for an angle, what you'll always do is you'll take what's called the inverse tangent of that number. Just a button on your calculator. I'm doing it here on my screen now. So inverse tangent of 3 over 2. I get about 56.3 degrees for that angle. So this angle is 56.3 degrees. Now remember, the sum of the two acute angles on a right triangle is 90. So this angle has to be 90 minus 56.3, which I think is 33.7 degrees. All right, so just a quick kind of recap of the notes. We'll do the special right triangles next time when we get together. Let's see. If you want to stick around, I'll do these problems here. So I'll do them now. So we have find the three trig functions: sine of theta, cosine theta, tangent of theta. I think the only one I know right away is the adjacent and the hypotenuse. So I know that the cosine is 10 over 18, which is 5 over 9. The other two trig functions require me to know the opposite side, so I'm going to have to do the Pythagorean theorem. So 10 squared plus b squared equals 18 squared. I think that's 324. B squared is 224, which is 4 times 56, yuck, which is 16 times 18, no, 16 times 14. I think B is 4 radical 14. Yeah, it is. So then my sine of theta is the opposite, 4 radical 14. So 4 radical 14 over 10, which is 2 radical 14 over 5. Tangent of theta is the opposite side, 4 radical 14 over 18. That's 2 radical 14 over 9. Okay, number 2, let theta be an acute angle of a right triangle. Evaluate the other two trig functions if the tangent of this angle is 4/9. So the opposite over the adjacent is 4/9. I need to find that missing side. So I'm finding the hypotenuse. 16 plus 81 is c squared. C squared is 97. C is radical 97. So I want to find the sine of theta, the opposite over the hypotenuse. We'll rationalize that in a minute. Cosine of theta is the adjacent over the hypotenuse. So if I clean this up, I get sine theta is 4 radical 97 over 97. The cosine is 9 radical 97 over 97. And we're done. Number 3, find the exact value of x. You will not be able to do this based on what we talked about today. You could using trigonometry. I'm going to save that problem. It's more of what we call a special case. Number 4 is calculator based. Make sure you're in degree mode. I'm not going to do this one now. Number 5, find the measure of everything. Okay, so I have angle B is 36, and that means that angle A, the other acute angle, must be the complement to that, which is 54. So if I have here, I've got a 36, 54, 90. I can do better than that. Right, A, B, right angle, 36, 54. A is 23. I made a mistake there. All right, angle A is 54. Okay, let's find this side here. We can do sine because I've got 54 degrees. I've got the opposite. I could say the sine of 54 is the opposite over the adjacent. I'm going to change my mind on that. I'd rather have the x in the numerator. I'll explain why in a second, or I'll show you why. I'm going to stick with b. I'm going to say the tangent of b. So tangent of 36 degrees equals x over 23. If If I can get that x in the numerator, it's going to be easy to isolate, because all I have to do is multiply both sides by 23. All right, so x equals 23 tan 36. So where is my calculator? 23 tan 36. I get about 16.7 for x. And the hypotenuse, I mean, you could do Pythagorean theorem, you could do trig, whatever makes you happy there. Let's see what we're going to do for that. How about sine? Let's do like the sine of 54. We'll call that y. Now, the only bad thing about it is it's going to put the variable in the denominator. It's going to be a kind of a pain, but not really. So I have the sine of 54 equals the opposite over the hypotenuse. So I'm going to multiply both sides by y and get y. Sine 54 is 23. So now to solve for y, I need to divide by sine of 54. It's like an extra step. So I do 23 divided by the sine of 54. I get 28.4. And now we have every piece of information that we need. All the other three sides. Okay. Now finally for part B, we'll wrap up with this one here. So we have, I'll do a different color so it stands out. I'll do black. So now I've got, I'll just label this angle right here. So A is 8, C is 12.8. So now we're going to do Pythagorean, this one's actually easier. We're going to do Pythagorean theorem to get B. So 8 squared plus B squared equals 12.8 squared. 64 plus B squared equals, I can't do that in my head. 12.8 squared is 163.84. So if I subtract 64, I get 99.84. And the square root of that is 9.99. So this number, I mean, call it 10.0 if you want. I'm going to call it 10.0. And then to find this angle, the two angles, I'm going to find this one first. I can do, I'm going to stick with the numbers they gave me, which was the 8 and the 12.8. That's the adjacent and hypotenuse for B. So I'm going to say the cosine of B is equal to 8 over 12.8. So B is the inverse cosine of 8 over 12.8. And let's see what happens. Inverse cosine of 8 over 12.8. I get 51.3 degrees. And if that's 51.3 degrees, the other acute angle is the complement of that, which is 37.7 or 38.7 degrees. Okay, so just a quick intro. I wanted to get this done so you have something to refer to if you're in school today and looking at it, or you can look at it over the weekend as well. So thank you so much for your time, and we'll see you guys very, very soon.